Okay, question 13. If x is greater than 3, which of the following is equivalent to this? Right, so the first thing I would like to do is to combine these two separate terms into one. And the way that I do it is via a cross multiplication. So we keep in mind that anytime we have a binomial in a fraction, we always want to put parentheses around it. Now, the way that the cross multiply works is that I cross multiply these, and that gets me 1 times x plus 3, or just x plus 3. Then I put the plus symbol from the center in between, and then I do the other cross multiply, which is this side, and that's 1 times x plus 2, or x plus 2. Now that gives me my numerator. Then I just have to divide by the product of the denominators. So x plus 3 and times x plus 2. Right, so now I just combine like terms on this level, and that's x plus x is 2x, and 3 plus 2 is 5. Okay, so I have that divided by x plus 3 times x plus 2. Okay, now whenever I have 1 over a fraction, that just means I need to flip the fraction. So I have x plus 3, x plus 2 divided by 2x plus 5. And now I just have to FOIL out the numerator. So that gives me x squared plus 3x plus 2x plus 6 over 2x plus 5. And then just combine the two middle terms here. So I get x squared plus 5x plus 6 over 2x plus 5. Answer choice B. All right, 14 is next. 3x minus y equals 12. What is the value of 8 to the x over 2 to the y? So the first thing I notice is that I might be able to rewrite this in terms of a power of 2. So I might write it as, since 8 is equal to 2 to the third power, I would write it as 2 to the third power to the x over 2 to the y. Then I would realize that I can multiply those powers, and I get 2 to the 3x over 2 to the y. So that I use the exponent rule for multiplying when you have a power raised to another power. Now I'll use the subtraction rule to get 2 to the power 3x minus y, and then all of a sudden I notice that this is simply equal to 12, and it's no coincidence that that is the case. Okay, so we get 2 to the power 12 as our answer, choice A. Question 15. All right, so here I just need to FOIL this out, and then it would look more like what we have on this side. The other option, of course, is to factor this, but that's a lot more complicated of an option. So let's go with the foiling. So we get a times b times x squared plus, and you could do outer or inner first, but I like to usually do inner first, 2 times bx plus 7 times ax, and then the last would be 14. That's equal to 15x squared plus cx plus 14. Now my first move is to subtract 14 from both sides, canceling it out. Next, what I can consider is that there's an x squared term here, and there's also one here. So as it turns out, these have to be equal to each other. So abx squared will have to equal 15x squared. And similarly, here I have two x terms, and here I just have the one x term. So these also have to be equal to each other in total. Okay. So now I can divide by x squared on both sides, canceling it out. I get ab equals 15. That's my first equation. Then from here, I can divide by x everywhere, canceling it out, so long as x doesn't equal 0. So I get that 2b plus 7a is equal to c. That's another equation. And I've introduced another variable here, c, so now I need 3 equations since I have 3 unknowns. But luckily they gave us another equation here, which is that a plus b is equal to 8. So now what I'd like to do is I'd like to use these two equations in order to figure out what a and b are, and then we could figure out c based on this equation, seeing as they're asking for c, right? So what I'll do here is I'll solve for a. So subtract b from both sides, I get 8 minus b. Then I grab this and plug it in for a. So I get 8 minus b times b equals 15. I distribute the b. I get 8b minus b squared equals 15. Then I swing the 15 over. So 8b minus b squared minus 15 equals 0. then I switch every single sign. So I get minus 8b plus b squared plus 15 equals 0. Rearrange it so that it's in a nice order. Of course, you move the sign along with the number. So, for example, this would be moved with its sign in front. Then we can just factor from here. So we factor it into two binomials, and we have the same signs, and they're both negative. Okay, and then we have 15. We have to factor it into 5 and 3. Well, in general, you would start with 1 and 15, and then do 3 and 5. So 3 and 5 is the one that's going to work. So we could put the bigger number here, and then we can t-chart. So b minus 5 equals 0, b minus 3 equals 0, and we can add 5, add 5. So b equals 5, add 3, b equals 3. So the two solutions we get are b equals 3 and b equals 5. Now when we plug them back into here, if we plug in 5, we get a equals 3, and if we plug in 3, we get a equals 5. So basically what that shows us is that our pair of numbers a, b are going to equal 3, 5 in either order that we choose. Okay, so let's plug in the 3 and 5 in first for a and b. So 3 and 5. So 21 plus 10 is 31. Then if we plug them in the other way, with the 3 going here and the 5 going here, we'll get 6 and 35, which is 41. So our answers for C are 31 and 41 respectively, so we get choice D.